In this problem it says a 20.0 kilogram sled is being pulled across a horizontal surface at a constant velocity. The pulling force has a magnitude of 80 newtons and is directed at an angle of 30 degrees above the horizontal. Determine the coefficient of kinetic friction. It doesn't say anything of a kid sitting on the sled or lying down on the sled. It doesn't say anything about snow, but those are the pictures that I got from the book, so let's use them. It also doesn't say, it says constant velocity, so actually let me write that down, constant velocity. It doesn't say to the right, but I just figured that I'm going to use it to the right because it could be that we have some negatives coming in here or not, and it's always nice to, if we can, set up a problem to the right so we can avoid unnecessary negatives, and sometimes we do need one or two, and I'll point that out in just a moment. That constant velocity actually will tell us something right away, and that is that the acceleration is 0. That's an important thing to know. Okay. Then what we have given is that the mass of the sled is 20.0 kilograms. We have given that the angle is 30 degrees with the positive horizontal. Maybe that's also another reason why I chose the direction to the right, so we already have it to the positive horizontal and we don't have to think anymore. Just plug in the 30 degrees, have the cosine here and the sine in the vertical. The force with which is being pulled, I'm going to call it Fp, the pulling force, equals 80.0 newtons. Okay. Alright. In this case, actually, down here, what I have in here is the weight. What I have in here is the normal force. And then I also have the pulling force in here. So like that. And overall, these four force vectors should come out to 0, have to come out to 0 because the sum of the forces need to be 0 in order for the acceleration to be 0. And that also means that I should make the normal force a little bit smaller. So let's see if this works. And the reason is that as we're pulling the sled up, the surface actually is supplying less force, so there's less normal force from the surface, so this one should be shorter, and then again, if you put all these four vectors together, you come out with net force of 0. Okay, let's see what else we need. As far as the forces are concerned, we have given the force with which it's being pulled. We have given the weight. The weight is readily over here. Weight equals negative 19.6 newtons. I'm sorry, negative 196 newtons. Then the frictional force, but we don't know that, and we kind of have to know it at some point because it says in the problem, determine the coefficient of kinetic friction. So at some point we have to come up with the frictional force. And then we also don't know the normal force, and even though they're not asking for it, I still make a couple of question marks to indicate that among the four forces that I've indicated, we don't know two of those, which means that we should end up with two equations in order to solve for this here. Okay, we do know what the mass is, and we do know what the acceleration is. Acceleration, of course, is 0. Okay, so now I'm going to write this down. Sum of the forces equals mass times acceleration. And here are the forces we have. The pulling force, the weight, the normal force, and the frictional force equals mass times acceleration. Acceleration is 0, so we come up with 0. Okay, notice again I put everything to be positive here. So I add them just like it says here, sum of the forces. In this case I have to also write vectors because we have one vector that is pointing in the horizontal, we have a couple of vectors that point in the vertical, and then we have one vector that points in both directions, the pulling force. So I have to still write them as vectors, and the only way I really can do that is by adhering to that this is a sum of, and then plug in the negatives later. Okay, what are we going to do now? Well, what should be happening is that it's constant velocity, so it's being pulled in a constant velocity to the right, so that means there is no acceleration in the horizontal and there's no acceleration in the vertical. So what we're going to do is we take it apart into the two directions, one in the x direction and the other one in the y direction. So in the x direction there is no acceleration, so I'm going to write that 0 here down right away, and then the y direction I'm going to write that 0 down right away. And now let's see what we get. In the x direction we have the pulling force, that would be eventually the 80 newtons, times the cosine of the angle. Our angle is 30 degrees, cosine of 30 degrees is positive, so that makes sense, that's positive. The weight in the horizontal, well, there is no weight in the horizontal, so it's 0. The normal force in the horizontal, well, there is no normal force in the horizontal, so that's 0. And then we have the frictional force. Okay, now remember that I said that this one here is positive, which makes sense because it's being pulled to the right. That means that this one here has to be negative in order to come up with a 0, and we can also see from the drawing that this one here should be negative. And now I had to do something about the equation that's given in the book. In the book it says kinetic friction equals coefficient of kinetic friction times the normal force. But notice that this is really a little bit tricky here because the normal force is vertical and the frictional force is horizontal. So how do I get a horizontal out of a vertical? Well, you leave out the vector signs. Alright, but then also notice that the normal force is up and the kinetic friction is to the left. So in this case I have to introduce that negative simply by looking at the situation and saying my kinetic friction has to be to the left. With a positive number here and a positive number here, I have to write a negative in front of that. I indicated that in blue. So in this one here, yeah, we're gonna, let's see, we can actually, oh yeah, in this case here we already figure out what the frictional force is. Fk equals negative Fp cosine theta. So that comes out to a negative, and that's what we said. This one here has to come out to negative. Okay, now in the y direction we have the pulling force times sine theta. Sine of 30 degrees is positive, and that makes sense because the pulling force is also pulling up, plus the weight, and that of course is negative, so here we have a positive and here we have a negative, plus the normal force, which itself is positive, plus the friction, which doesn't exist in the vertical because it's just on the horizontal. Okay, in this equation we have everything given here, 80 newtons, sine of 30 degrees, minus 196, except for the normal force that we don't have, so we calculate this one from here. Normal force equals minus Fp sine theta minus W equals